Welcome. Today, we are adding a seriously powerful tool to your calculus toolkit. I'm talking about those integrals that make you stare at the page wondering where to even start. If you've ever been stumped by one of those, this explainer is for you.
Okay, so let's get right into it. We all have our go-to methods, right? But sometimes, especially as the problems get more complex, those usual methods just don't cut it.
For example, take a look at this, the integral of x times sine of x. Just think about it for a second. How would you tackle this one? It's not immediately obvious, is it? Yeah, if your first thought was u substitution, you probably hit a brick wall almost instantly. No matter what you choose for u, the other part doesn't clean up nicely. So clearly, we need something new in our arsenal.
And that new approach is called integration by parts. Honestly, the best way to wrap your head around it is to think of the product rule for differentiation, but you're just running it completely backward. It's a method that's tailor-made for integrals that are a product of two functions, just like the one that stumped us.
So let's break down the mechanics. We're going to look at the core formula itself, and then, probably even more important, the one simple rule that makes this whole thing work smoothly. And here it is. The integral of u dv equals uv minus the integral of v du. Now, the magic here isn't that we're solving the integral head-on. No. The whole point is to strategically trade the complicated integral we start with on the left for, hopefully, a much easier one on the right. But that brings up the million-dollar question, doesn't it? How in the world do you decide which part of your integral is the u and which part is the dv? Because let me tell you, if you choose wrong, you can actually make the problem even harder. But don't worry, there's a trick for this. And here is your new best friend, the ILATE rule, I-L-A-T-E. Seriously, commit this to memory. This is your secret weapon for choosing u every single time. You just look at the functions in your problem and you pick your u based on whatever function type shows up first on this list. So you start with inverse trig, then logarithmic, algebraic, trigonometric, and way down at the bottom, exponential. All right, theory's great, but let's see it in action. We're going to go back to that very first problem, the integral of x sine of x, and solve it step by step. Okay, step 1, choose u and dv. First, we identify our function types. We've got x, which is algebraic, and sine of x, which is trigonometric. Now we pull out our ILATE rule. In ILATE, a for algebraic comes before t for trig, so our choice is made for us. U has to be x. That means everything else left over, the sine of x dx. That becomes our dv. On to step 2. Our formula needs 4 pieces, and right now we only have 2. We need do and v. Well, to get do, we just differentiate our u. Since u is x, du is just dx. Simple. To get v, we integrate dv, and the integral of sine x is negative cos x. And just like that, we've got all 4 pieces of our puzzle ready to go. And here comes the satisfying part. We just plug everything into the formula, we substitute our pieces in, we simplify it a little bit, and would you look at that? The integral we're left with is just the integral of cos of x dx. That's a piece of cake. So our final answer is negative x cos of x plus sine of x, and of course you can't forget the all-important constant of integration, plus c. Okay, that's the standard playbook. You've got the basics down. Now, let's level up and look at a couple of advanced tricks that really show how flexible this technique can be. So, what happens if it looks like there's only one function? For instance, how would you evaluate the integral of the natural log of x? I mean, there's no obvious product here, right? It seems like this method shouldn't even work. But this is where we get a little sneaky. It's called the invisible 1 trick. All we do is pretend that dx is actually 1 times dx. By doing that, we've basically created a second function out of thin air, the algebraic function 1, and now we can use integration by parts. It's so clever. So let's run the play. We use ILATE. Logarithmic is super high on the list, so u is definitely ln x. That means dv has to be our invisible 1 dx. We find du and v, pop them into the formula, and it simplifies just beautifully. The final answer is x ln x minus x plus c. It's a really elegant solution to a problem that looked impossible at first. All right, now for the boss level. This is a classic, famous problem that I like to call the infinite loop. This is where things get really interesting, and it requires a little bit of out-of-the-box thinking. So we're trying to solve the integral of e to the x times sine x. In round 1, we apply integration by parts, and we get a new integral. Okay, no big deal. We just apply the technique again to that integral. But then look what happens in round 2. The original integral, the one we started with, has just shown up again on the right side of our equation.
It feels like we're stuck in a loop, right? We're right back where we started. The very thing we're trying to solve for is now on both sides of the equal sign. It seems like we could do this forever and get nowhere. So, what now?
And here is the absolutely brilliant move. The solution isn't more calculus. It's just some simple algebra. Let's just call our original integral I. Now look at the equation. We can just add I to both sides of the equation. That gives us 2I on the left. Then all we have to do is divide by 2 to solve for I. We solve for the integral without actually doing the final integration. It's an amazing, amazing trick. So let's bring it all home. What's the big takeaway from all this? It really is about mastering this idea of the product rule in reverse and knowing which strategy to use when.
Okay, here are the key things you've got to remember. You use this technique for integrals of products. Remember, it's just the reverse of the product rule. Most importantly, always, always use the I-late mnemonic to pick your U. That's the number one place people trip up. Remember, you're trading a hard integral for an easy one. And finally, if you see that infinite loop, don't panic. Just use algebra.
And that's a wrap on integration by parts. So I'll leave you with this question. Now that you have this powerful new tool in your arsenal, what other tough integrals are you going to be able to unlock?